What is up everyone, Rex here and welcome to the first video of VFX walk cycles, a series in which we will learn how we can make any 2D object walk on any 3D terrain dynamically and procedurally. This particular video dwells into shooting the footage and extracting the location and rotation from that footage into our 3D world. So without any further ado, let's get into it. Alright, first let's focus on shooting. What are the equipments we're gonna need for this shoot? So the only essential equipment requirement for shooting is a camera and a person walking. But I'm gonna be very honest with you, if you want the results to be as realistic as possible, you're gonna need more than just essential requirement. What my recommendations would be for the equipment would be first, a camera that can shoot 4K. Second, a camera in which you can control the shutter speed. Third, a camera which involves stabilization either through its lenses or its digital technology. Mark my words, the better the shooting, the better the motion tracking. The better the motion tracking, the more realistic the results are gonna be. Now, other than the equipment essentials, you're also gonna need two shooting essentials. First, your entire body needs to be in frame at all point of time. Even if a small part of your body moves out of the canvas of the camera, the illusion will break. Second essential is that you're gonna need to walk on a flat surface. Avoid incline and decline surfaces or the illusion will break. Alright, so why am I stretching so much out on that illusion? Well, the thing is, we are importing a 2D footage into a 3D world. We have one dimension missing. That missing dimension causes hell ton of problems. To avoid these problems, we fake the existence of the missing dimension, making that missing dimension go unnoticed. Now, the best scenario for shooting the video would be you walking on a treadmill followed by a green screen background. But that's not feasible for everyone, including me. So the sample footage I'm going to use for this entire series is me walking followed by a handheld shaky camera. I'm doing this only to prove that this workflow works on non-perfect shots as well. But if your shot is kind of too far away from perfect, it's gonna cause problems, and we'll discuss how we can solve those problems. Also, a quick note I'd like to make is that a person moving in length or height would be easier to integrate into the 3D world rather than moving in depth. But again, because I choose to use a non-perfect shot, I'll be moving in length, height and depth. Alright, so now that we've discussed about shooting, let's talk about tracking. By tracking, I specifically mean camera tracking and object tracking. The process involves using high contrast points to track the location and rotation of the 2D footage and recreate the same location and rotation in the 3D world. We will talk about high contrast markers further in this video, but for now I need you to understand there need to be points in the footage which are different from the surroundings. So here's what I did. I just found a great VFX marker on the internet, gave ChatGPT a command to make a grid of it, and using my 9th grade craft skills, I cut them out and sticked them on my clothes. Then I got my expert cinematographer and got shooting. After 3 to 4 takes, I had the shot I was looking for. Now for motion tracking, I'm gonna be using Blender. So just select VFX and import your footage. Now I'm not going to teach you how to motion track because there are plenty of good YouTube tutorials already on it. But basically you select a point and trace it either automatically or manually till the point dies. Now what I do want you to know, when you are tracking the camera, don't let the points on your body be the markers. And when you're shooting for the objects, only use points on your body as the markers. The footage is tracked and now let's see the solve error. It should be under 1. The footage is shaky. Therefore, the software cannot calculate the camera or the object properly. Just like you, my footage is not good enough to be tracked. But I'm going to show you a workaround around this where you can achieve the results without motion tracking. But if your solve error is good enough to be under 1, follow these next steps. Add a null, go to constraints property and add a camera solver. Get a limit location, enable all values and set them all to 0. Name it camera rotation. Get another null and this time add an object solver. Get a limit rotation and enable and set all values to 0. Name it object location. So what we have done here is that we have basically extracted the camera rotation and object location. What are we going to do with it? You'll see in the further videos. What if we can't do this? You'll see in the further videos. Now for the final part of the video, we're gonna be needing to suck the location and rotation out of our footage so we can add custom location and rotation to it later on. Now I couldn't really find a software which exactly does this, so I went a little off track and used a Python script to do so. To do that, we first need to separate ourselves or the object from the rest of the footage. I used roto brushing to do it. also turn the video into an image sequence. You can use keying, masking it out manually, or any other means to separate yourself from the background. Now if you don't have Python, there are plenty of good tutorials on the net which tell you how to install it. So first install Python and then install these libraries. Now open your Python ideally and paste in this code. I'm not gonna go in detail of what this code does line by line, but if you really want to understand what this code does, let me know and I'll make a video on it. Comment. Now what I want the Python code to do is find the first non-alpha pixel from the bottom and calculate 800 pixels above it and use that as a reference to center the object. Now this code does exactly so. If you want this code in text form, just message me on my Instagram page and I'll send it to you. Now after pasting the code, you just need to put 4 values: input folder, output folder, frame height and reference height. Frame height basically means the amount of pixels you're gonna get in the height of the exported images. Now the reference height means how many pixels you want to calculate from the bottommost non-alpha point in the up direction. Now for the last part, open Houdini, create a geometry node and search for a very powerful node called trace. This node is gonna be the backbone of our VFX walk cycle because it converts an image into a mesh using the alpha channel. Now naming the exported images is very essential, otherwise Houdini won't recognize it as a sequence. Go to your output folder, select all images, go to the first image, right click and rename, hit 1 and then hit enter. Now all of your images are stored in the name of one in bracket $f. $f means current frame. Select the image sequence and bring it in the trace node. Now go to filter, enable whole faces, and if your object has too many points, you can go to resample shapes and increase the step size. Now get a time shift node, delete the channels and set it to frame 1. Get a match size node, plug in the trace node into the first input and the time shift node in the second input. Now disable translate and enable scale to fit and uniform scale. Set the scale axis to Y. Now if you play the timeline, you're gonna notice that the shape of our object at all frames is the same. Well, that's it for this video. We have laid down the foundation of our VFX walk cycle. In the next video, we're gonna learn how we can animate and simulate the movement of our object on any 3D terrain. So, well, that's it for now and I'll see you in the next video. Bye bye.